Hi and welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to describe what's meant by a resistor. You should then be able to recognize the symbol for a resistor. And finally, you should be able to describe the current potential difference graph for an ohmic conductor. This last point sounds tricky, but it's not really. In the last video, we started looking at the idea of resistance. Remember that an electric current is simply a flow of electrons. As the electrons move through a conductor, they collide with atoms in the metal. This causes the electrical energy carried by the electrons to transfer into other forms of energy such as thermal. The resistance simply tells us the potential difference required to drive a current through a component. And remember that the higher the resistance, the more energy is transferred as the current moves. We calculate resistance by dividing the potential difference by the current. And remember that the unit of resistance is the ohm. Now, you might be thinking that resistance is a bad thing. Why would we want to waste energy moving a current through a component? And in some ways you'd be correct. A lot of energy is wasted due to resistance. But sometimes resistance can be really useful. Sometimes we want to add resistance into a circuit, and to do that we use a resistor. I'm showing you some resistors here. We can get resistors with any resistance that we need. Here's the symbol for a resistor, and you need to learn that. So why would we need to add extra resistance? Looking at this circuit, you can see that I've got a lamp connected to a cell. The potential difference across the lamp is 20 volts, and the lamp is very bright. Now, if I wanted to make the lamp dimmer, I could use a cell with a lower potential difference, or I could add extra resistance into the circuit. So here I've added a resistor in series with the lamp. Now the potential difference is shared between the lamp and the resistor. This means that less electrical energy is transferred to the lamp, so it's not as bright as before. So as you can see, resistors can be very useful in circuits. Take a look at this circuit. Here we have a resistor connected to a cell. The resistor has a potential difference of 10 volts, and a current of 0.1 amperes is flowing. We can calculate the resistance of the resistor using the equation R equals V divided by I. V is the potential difference, which is 10 volts. I is the current, and that's 0.1 amperes. So the resistance is 10 divided by 0.1, which gives us a value of 100 ohms. So what would happen to the current flowing through the resistor if we increase the potential difference? We're going to look at that now. I'm going to increase the potential difference across the resistor and measure the current flowing. And I'm going to plot my results on the graph here. So a potential difference of 0 volts gives us a current of 0 amperes. That makes sense because if the potential difference is 0, then the electrons have got no energy, so they cannot move through the resistor. Here's that result on the graph. Increasing the potential difference to 10 volts gives us a current of 0.1 amperes, and here it is on the graph. Increasing the potential difference to 20 volts gives us a current of 0.2 amperes, and again, here it is on the graph. Now I'm going to keep increasing the potential difference by 10 volts each time and plotting the current on the graph. So here are my final results. As you can see, we've got a straight line passing through 0. This tells us that the current moving through a resistor is directly proportional to the potential difference across the resistor. What this means is that the resistance is constant. The resistance does not change if we increase the current. We call this kind of resistor an ohmic conductor. Now there's one really important point about this which you need to learn. The resistance will only stay constant if the temperature is constant. Now in later videos, we're going to look at examples where this is not true. Remember, you'll find plenty of questions on resistors in my revision workbook, which you can get by clicking on the link above. Okay, so hopefully now you should be able to describe what's meant by a resistor. You should then be able to recognize the symbol for a resistor. And finally, you should be able to describe the current potential difference graph for an ohmic conductor.